Welcome back to Moose in Chemistry. This lesson is about electron configuration, Hunds rule, lesson 1. Alright, now let's look at Hunds rule. Hunds rule states that orbitals of equal energy are each occupied by one electron before any other orbital is occupied by a second electron. And all electrons in a singular occupied orbitals must have the same spin. Okay, so what does that really look like? Well, let's take a look at this. So we're going to go ahead and put this down. And what we're saying is this, that you must have a single electron going in the same direction. That's an upspin, which we call clockwise, before you can start your downspins, which are your counterclockwise spins. So your upspin is clockwise, and your downspin for the electron is counterclockwise in its spin. Okay, so let's look at a couple of things while we're getting ready to do Hunds rule. Remember that S can hold 2 electrons, the S shell. The P shell can hold 6 electrons. The D shell can hold 10 electrons. And the F shell can hold 14 electrons. So what does that really mean? Well, let's clear everything here, and we'll look at it in another way. So when we look at this, again, we said that S equals 2 electrons, P equals 6 electrons, D equals 10 electrons, and F equals 14 electrons. So in essence, what we're saying is that this has 1 orbit. This has 3 suborbits. This has 5 suborbits, and this one has 7 suborbits. Alright, so now let's look at it from another way. If we take an atom such as carbon, so we look at carbon. Carbon has an atomic number of 6. So remember that the number of protons is equal to the number of electrons in a neutral atom. So that means we have 6 electrons. So when we write our electron configuration, it's 1s2, 2s2, 2p2, using the diagonal rule that we learned in our other lesson. So what does this really look like with Hunds rule? So again, let's write it down here. 1s2, 2s2, 2p2. So now, with 1s in Hunds rule, you only have 1 orbit there. So we put an up arrow and a down arrow because we have 2 electrons. Now, under 2s, the same thing. We only have 2 electrons. So we do an up arrow and a down arrow. Now, with 2p, there are 3 orbits. So we're going to call that 2px, 2py, 2pz. So we're going to go an up arrow, up arrow. And again, we're not going to fill anything in the z because we don't have any more electrons. We ran out of electrons, but we still have to have it there because it does exist. Alright, I've cleared the last drawings out, and now what I've drawn for you are the actual orbits and the suborbits. So if you have an S shell, it is denoted by just this 1s because it will hold a max of 2 electrons. If you are in the P shell, at any energy level, you will have, here's your P shell with a max of 6 electrons. And notice that it's Px, Py, Pz. With the D shell, you can hold up to 10 valence electrons, or 10 electrons in general. So the D has 10 electrons. and that is denoted as dx squared minus y squared dxy, dyz, dxz, and dz squared. Last but not least is the giant f suborbitals, and there are 7 of those, which gives us a total of 14 electrons for the f orbits, and they are fz cubed, fxz squared, fyz squared, fxyz, fz bracket x squared minus y squared, fx x squared minus 3y squared, fy bracket 3x squared minus y squared. And they can hold, again, up to 14 electrons. So let's look at an electron configuration for, let's say, a p block element like chlorine. So chlorine has an atomic number of 17, which also means it must have 17 electrons. So remember the rule that we had, that we used 1s like that, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. So we're going to fill using the diagonal rule, which is the off-ball principle, like so. Okay, like that. So now we have 17 electrons. So we start off with 1s2, because remember that s holds 2 electrons. 2s2, then 2p6. Now we used a total of 10 electrons so far. So then we go to 3s2, and then 3p5. Now that's a total of 17 electrons. And that's doing electron configuration. Now let's put this in orbital notation, which we call Hunds rule. So you would say 1s up and down, 2s up and down, 2px, 2py, 2pz. You have 6 electrons, so go 1, 2, 3, 4, 5, and 6. Our 3s is going to be up and down. Then we're going to have 3px, 3py, and then 3pz. So we're going to go 1, 2, 3, 4, 5. And that is the orbital notation, which I call ON for the element chlorine. And this one we call the EC, the electron configuration for chlorine. In future videos, we'll be talking more about the D shells and the F shells. And you guys practice some of these problems and have an amazing day.